Hello everyone. Today I am going to tell about subsets of set of real numbers and examples and the solutions of exercise 1.3 from Ncert. Now I am going to tell what is a subset. A set A is said to be a subset of a set B if every element of A is also an element of B. So here the subset is denoted by this symbol and it is the subset of or contain in. If you see the examples, you will understand. See here A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4, 5, 6. So here all the elements of the A are also the elements of B. So here A is subset of B. And you can write the same thing. A is subset of B if and only if A belongs to A, that implies A belongs to B. So here small a is every element of A. For example, small a is 1. 1 belongs to A. So 1 also belongs to B. And 2, if A is 2, small a is 2, then 2 belongs to A. Then 2 is also belongs to B. So this is the meaning of subset. And the other examples you can see here, C is equal to -2, -4. These are integers. Then D is equal to -4, -3. This is the set of D. Then you can check here the elements of C are also the elements of D. Here -2, -4 are also there. So we can say that C is subset of D. And next example, E is equal to, there is only one element, that is E. So you can see here in F set, you can see E element here also. So we can write E is subset of F. And if you see this example, here A is equal to 1, 3, 5. Then B is equal to 1, 2, 3, 4. So 1, 3 elements are also the elements of B, but 5 is not in B. So 5 belongs to A, but 5 does not belongs to B. So A is not a subset of B. These are some results of subsets. The first one is if A is subset of B and B is subset of A, then A is equal to B. For example, if A is equal to 1, 2, 3 and B is equal to 3, 2, 1, here all the elements of A are also all the elements of B, and all the elements of B are also all the elements of A. That means A is subset of B and B is subset of A. So here these two sets are equal. That means A is equal to B. And in the second one, A is equal to 1, 2, 3, B is equal to 1, 2, 3, 4, 5. If you see A is subset of B because all the elements of A are also all the elements of B. But here 4, 5 are not in A. So all the elements of B are not all the elements of A. So here B is not subset of A. So in this case, A is not equal to B. That means these two are not equal sets. So in this case, A is said to be proper subset of B and B is superset. And third one, this is a third result of subsets. Every set is a subset of itself. Yes, it is true because if you see here, for example, A is equal to 3, 2, 1. So here A is subset of A. Every set is a subset of itself. And next one is empty set is a subset of every set. We know that empty set or void set or null set means there are no elements. For example, A is equal to empty set and B is equal to 3, 2, 1. So here A is subset of B. All empty sets are subsets of any sets. So you have to remember this. And next one, this is an important point. The total number of subsets of a finite set is 2 to the power of n. For example, here n is number of elements. The total number of subsets of a finite set. We know that finite set means it is a countable elements. The set should be countable elements. For example, if A is subset of B and B is equal to 1, 2. For example, B is this set 1, 2. Here n is equal to 2. There are 2 elements. So n is equal to 2. Therefore, the total number of subsets, the number of subsets here is equal to 2 to the power of n is equal to 2 square. N is 2. So 2 square, that is 4. So here the total number of subsets of a finite set. Here B is a finite set. That is countable number of elements. 1, 2 you can count. So this is finite set. So the total number of subsets of B here is 4. And you can check like this here. For example, you can write for this set, you can write the subset of B. You can write 1, 2. This is a subset of B, and only 1 is also subset of B. Only 2 is also subset of B, or empty set. Just now I told you, empty set is also the subset of any set. So here 1, 2, 3, 4. You can create 4 subsets for this set. So the total number of subsets you can use by using 2 to the power of n directly. Without writing these subsets, you can directly calculate this. And second example, B is equal to 1, 2, 3. Here there are 3 elements. So 2 to the power of n is equal to 2 cube, that is 8. You can check here. You can write the subsets like this. For B, you can write 1 is subset, and 2 is also subset, 3 is also subset, 1, 2, 2, 3, 1, 3, 1, 2, 3, and empty set. There are 8. So here there are 4, here there are 8. So the total number of subsets of a finite set is 2 to the power of n. Next one, if a set has only one element, then it is a singleton set. So if the set is has only one element like this, for example, A is equal to 1, there is only one element. Here also B is having only one element. So these sets are called singleton sets. Now I am going to tell the subsets of real numbers. So before going to write the subsets of real numbers, we have to know about what are real numbers. So you just know about all the numbers. For example, natural numbers, we know that this is the natural numbers. N is equal to, it starts from 1, 2, 3, etc. And whole numbers, these are including the natural numbers and 0. So whole numbers start from 0, 1, 2, 3. Next, natural numbers. So whole numbers include natural numbers. And next, integers, that is Z. Z is equal to, we know that integers are negative numbers, positive numbers, including 0. That means Z includes W and N, whole numbers and natural numbers. You can see from this figure. And Q is rational numbers. All rational numbers are in the form of P by Q, where Q is not equal to 0. So Q includes all the numbers, integers, that means that includes whole numbers and natural numbers also. Here 25 minus 8 and 0, all these are integers. So you can write these numbers in the P by Q form, like 25 by 1 minus 8 by 1, 0 by 2, like that you can write. So all these numbers are rational numbers, that is denoted by Q. And you know that the irrational numbers are like root 5, root 3, root 2, root 7, etc. These are separate numbers. So this is denoted by Q dash. So here real numbers includes all these rational numbers as well as irrational numbers. So this is the meaning of this figure. Here these are the irrational numbers. So these are the examples. This include, you can see the set here. This includes the rational numbers. That means it includes J, W and everything. And also irrational numbers, that means Q dash also. So real numbers includes rational numbers as well as irrational numbers also. So now you can write the subsets for real numbers. First see here natural numbers. So here n is subset of W. This is whole numbers. You can see here n is subset of W and n is subset of Z, n is subset of Z, and n is subset of Q, as well as n is subset of R. So this includes natural numbers also. So n is subset of R. And similarly, W, this is whole numbers. W is subset of Z, W is subset of Q, and W is subset of R also. And Z is subset of Q. Here Z means integers. Z is subset of Q, and Z is subset of R. And Q dash, that means, so here Q is subset of, Q means rational numbers. Q is subset of R. This is rational numbers. All rational numbers are subset of real numbers. And Q dash is also subset of R, because the irrational numbers also subset of real numbers. So from this you can write N is subset of W, that is whole numbers, is subset of Z, that is integers, that is subset of Q, rational numbers, subset of real numbers. So these are the subsets of all real numbers, and Q dash is also subset of real numbers, that is irrational numbers. So for real numbers, the subsets are natural numbers, whole numbers, integers, rational numbers, and irrational numbers. These are the subsets of real numbers. Now I am going to tell the solutions of examples from NCERT. This is example 9. Consider the sets. Here 4 sets are given. Insert the symbol subset is subset of or is not subset of between each of the following pair of sets. So here there are 4 pair of sets are given. You have to put these symbols. So first write the given sets here. Here 5 is an empty set. We know that there are no elements in an empty set. And A set is given, that is 1, 3, and B set is 1, 5, 9, C set is 1, 3, 5, 7, 9. So right here all these sets, the first one is 5 and B. You have to put the symbol between these two sets. We know that every empty set is a subset of every set. So here you have to put the subset of 5 is a subset of B. And next one is A and B. Between A and B, you can see here A elements are 1, 3 and B elements are 1, 5, 9. But here 3A belongs to A, but 3 does not belongs to A. So A is not a subset of B. And third one is AC. You have to check A and C. Here 1, 3 are elements of A and 1, 3 are elements of C also. So A is a subset of C. And next one is B and C. Here 1, 5, 9 are elements of B as well as elements of C also. So here B is a subset of C also. And next one, example 10. Let A is equal to AEIOU and B is equal to ABCD. Is A is a subset of B? Is B a subset of A? So here A is equal to AEIOU. This is a set of A and B is equal to ABCD. You have to check whether A is a subset of B. So here E is an element of A, but E is not an element of B. So A is not a subset of B. Similarly, B is an element of B, but B is not an element of A. So B is not a subset of A. Next one, example 11. This is an important example. So let A, B, and C be 3 sets. If A belongs to B and B is subset of C, is it true that A is subset of C? If not, give an example. So here there are 3 sets A, B, and C. So we have to assume these 3 sets. The first one, if A belongs to B. So let us assume A is equal to 1, 2. So in the A set, there are 2 elements, 1 and 2. Okay. Then here A belongs to B. So you have to assume B set. In that set, A belongs to B. That means A set is an element of B. That is 1, 2. This is A set. 1, 2 is A set. So this is an element of B. So write like this, 1, 2 in braces, comma, 3, comma, 4. You can assume any values here. But A element should be A set element A should be here. So B is equal to set A, comma, 3, comma, 4. Then B is subset of C. You have to assume C as B is subset of C. So B is a subset of C means all the elements of B should be in C. So you have to write all the elements of B in C set. So those are 1, 2. This is set, comma, 3, comma, 4, comma. You can assume any numbers, 5, 6, 7, 8 like that. You can assume any numbers. So now you have to check, is it true that A is subset of C? That means A is subset of C means you have to check whether all the elements of A should be all the elements of C. So here 1, 2, these are the elements of A. First element you check 1. 1 is not in the C set because here this is set. This is not element. 1, 2 is not an element. It is a set. So 1 element is not in C. So 1 belongs to A, but 1 does not belongs to C. Therefore, A is not a subset of C. Now I am going to tell the solutions of question 1 to question 5 from exercise 1.3 from NCERT. This is first one. Make correct statements by filling in the symbols is subset of or is not subset of in the blank spaces. So here some questions are given. The first one is the first set is 2, 3, 4 dash. The second set is 1, 2, 3, 4, 5. So you have to check whether the first set is a subset of the second set or not. So here all the elements of the first set are also all the elements of the second set. So here you have to put the subset of. The first set is a subset of second set. And second one, here the first set is A, B, C, and second one B, C, D. So here A belongs to the first set, but A does not belongs to the second set. So here A, B, C is not a subset of the second set, that is B, C, D. And this is third one. X such that X is a student of class 11 of your school. And the second set, X such that X is a student of your school. Yes, here students of any class, here class 11 students also includes the student of all the school, all the students of the school. So here students of any class of the school are also the students of the same school. So here you have to put the first set is a subset of the second set. Next one is X such that X is a circle in the plane, and in the second set, X is a circle in the same plane with radius 1 unit. So here given radius 1 unit, but here it is in this plane, it is need not be, the circle should be the radius of 1 unit because they can be any radius. So here it is not a subset of. Next one is X such that X is a triangle in a plane. Next set is X such that X is a rectangle in the plane. So here in this plane all are rectangles, in this plane all are triangles. So we know that set of rectangles does not contain any triangles. So here it is not a subset of the second set. It is not a subset. Next one is X such that X is an equilateral triangle in a plane. Second set, X is a triangle in the same plane. So equilateral triangle means all sides of the triangle are equal. So here in this plane, there are full of triangles. So out of these triangles, equilateral triangles also there because the triangles includes equilateral triangles also. So it is a subset of, the first set is a subset of second set. And this is seventh one. Here X is an even natural number and second set X is an integer. So integers means all the numbers include positive, negative numbers including 0 and even natural numbers. Natural numbers are 1, 2, 3, 4, etc. Out of these even natural numbers are divisible by 2, those numbers which are divisible by 2. So even natural numbers are 2, 4, 6, etc. These are called even natural numbers. So here the first set is whether it is a subset of second set or not, we have to check. Yes, because here 2, 4, 6 also, now the integers includes these numbers also even natural numbers. So here the first set is a subset of second set. This is second problem. Examine whether the following statements are true or false. The first one is, this is the first set, A, B are the elements of the first set and in the second set B, C, A are the elements. It is given that the first set is not a subset of the second set. But here the elements of the first set are the elements of the second set. So it is a subset of the second set. But here it is given not the subset. So the given statement is false. And next one, in the first set, the elements are A, E. And in the second set, X is a vowel in the English alphabet. We know that A, E, I, O, U are the vowels in the English alphabet. So here the first set elements are also the elements of the second set. And this is a subset of the second set. So here the given statement is true. This is third one. Here in the first set, 1, 2, 3 are the elements. In the second set, 1, 3, 5 are the elements. Here 1, 3 are also in the second set, but 2 belongs to this set, but 2 does not belongs to the second set. If you assume A as the first set and B as the second one, 2 belongs to A, but 2 does not belongs to B. Therefore, A is not a subset of B, but here it is given that it is subset of second set. Therefore, the given statement is false. And this is next one. Here, the only element in this set is A, and here the elements are A, B, C. Here A is subset of this set is subset of this set because the element of the first set are also the element of the second set. So it is true. The given statement is true. If you check the next one, see the difference between the previous one and this one. Here the set A belongs to this set ABC. Here it is not A belongs to A. Just check the difference here. This is subset. Here A is a subset. This set is subset of this set. But here A belongs to. This set belongs to the second set. That means here in the second set, A, B, C are the only elements of this set. But here the set, including the braces, it is not there. So it is not a correct statement. So the given statement is false. You can check here. Here A belongs to ABC. But this set does not belongs to ABC. If it is there including the braces, then it belongs to this set. But here it is only A belongs to ABC. So it is not correct. And next one, X is an even natural number less than 6. This is in the first set. And it is a subset of the second set. That is, X is a number which divides 36. So first, even natural numbers less than 6. Natural numbers means 1, 2, 3, 4, all these numbers. And even natural numbers. Even natural numbers means divisible by 2. Those numbers which are divisible by 2, those are 2, 4. Those are less than 6. That means 2, 4. So this is the first set. And in the second set, X is a number which divides 36. That means factors of 36. We know that the factors of 36 are 1, 2, 3, 4. These are divide. These number 36 divides this number. Then you will get remainder as 0. So here those numbers are 1, 2, 3, 4, etc. till 36. So here 2, 4 are the elements you can see in the first set. So it is a subset of the second set. Therefore, the given statement is true. This is our problem. Let A is equal to, these are the elements of A. Which of the following statements are incorrect and why? So here, if you check, there are 4 elements in A. Those are 1, 2, and this is 1 element. 3, 4 is 1 element because this is in a set, and 5 is one more element. So the first one is 3, 4 inside the braces. That is subset of A. So here you know that if one set is subset of the another set means you have to check all the elements in the first set should be in the second set. But here 3 does not belongs to A. 3 belongs to the first set, but 3 does not belongs to A. You can check here 3 is not here. Only 3, 4 is a set, but 3 does not belongs to A. So here this is incorrect. This statement is incorrect. If the elements are like this, then it is subset of A, or you can write this is belongs to A because this is an element. You can either change the symbol here or you can write the elements like this. Then this statement is correct. And second one, 3, 4 inside the braces belongs to A. So this is correct because this set is an element of A. So this statement is correct. And third one, here this element 3, 4 set is an element of A. This is again inside the braces. So this is again a set. This set is an element of another set. So this is subset of A. Correct, because the subset of A you can write as 1, 2, all are subsets of A. So this is also an element. So this is also a subset of A. So you can write like that. So it is subset of A is correct. And next one, 1 belongs to A. Yes, because 1 is an element of A. So 1 belongs to A. So this statement is correct. And next one, 1 is subset of A. Here 1 is an element of A, but it is not a subset of A. So it is incorrect statement. You can check here. Here 1, if you write 1 inside the braces, then it is a subset of A. Or you can write 1 belongs to A. So these two are correct. These two are correct statements. But the given statement is incorrect. The sixth one, here 1, 2, 5 inside the braces is a subset of A. This is one set. So this is subset of A. If you check the elements of the first set, here 1, 2, 5 are also in the A set. So this is correct because this is a subset of A. You can check here subsets of A are 1, 2, like this you can write. So here 1, 2, 5 is also a subset of A. So this is the correct statement. And next one, 1, 2, 5. This set belongs to A. This is not correct because this set is not an element of A. See here 1, 2, 5 set is not there. So this is not an element of A. So this is incorrect. You can check here if it is like this is an element of A, then you can write this belongs to this set belongs to A. This is next one. Here this set 1, 2, 3 is subset of A. You have to check the elements of the first set here. So here 1, 2 are there in the set A, but 3 is not there. 3 is not a separate element of A. So 3 does not belongs to A. So this set is not a subset of A. So it is incorrect statement because here 3, 4 is an element. This full is a set. This 3, 4 set is a full set. That is an element of A. But here 3 is not a separate element. If these elements are like this, then it is subset of A. This is the correct statement. But here, this is not correct. Next one is 5 belongs to A. We know that 5 is an empty set. There are no elements. So we know that every empty set is a subset of every set. But here, this is an element belongs to A means this is an element of A. That means it is not an element of A. You can see here there is no 5 element here in this set. It is subset of A, but it is not an element of A. So an empty set is a subset of every set, but it is not an element of the set. So you can see here 5 is a subset of A, but the 5 does not belongs to A. So this statement is incorrect. If this is like this, in A set, if the 5 element is there, then you can write 5 belongs to A. This is the correct statement if 5 is in the A elements. 5 is a subset of A. This is correct because we know that every empty set is the subset of every set. So it is correct statement. This is last one. You can check here. 5 in a set is subset of A. So here 5, this empty set is an element of this set. So you have to check whether this set is subset of A. So you have to check the elements of both sets. So this element is not in the A set. So 5 is not in the A set. So it is not true. So it is incorrect statement. If 5 is the element of A, then you can write this is subset of A like this. So this is incorrect. This is fourth problem. Write down all the subsets of the following sets. We can write a number of subsets for any set. We know that. So you can check by using the formula 2 to the power of n. I have already told in the starting itself. So you can check like this number of sets 2 to the power by using 2 to the power of n. Here n is the number of elements. So the first one is A. This is in a set. So here the number of elements are only 1. So subsets of the given set you can write as this one, the only one element. So A inside the braces, this is one set, one subset, and an empty set is subset of every set. So you can write the empty set also. So here there are 2 subsets for this given set. So you can check number of sets here is equal to 2 to the power of n, that is equal to here n is only one element, that is A. So 2 to the power of 1, that is equal to 2 sets. So here 2 sets. So here the number of sets are 2. Like this you can check. So next one is here the elements are A comma B. So you can write the subsets A and B. This is one set in one set and this is B is in another set. And A comma B, this is in another set and an empty set. So there are 4 subsets for this given set. So you can check like this 2 to the power of n is equal to here 2 elements A comma B. There are 2 elements. So 2 square that is equal to n is equal to 2. That is equal to 4 sets. So you can cross check here. There are 4 sets. And next one is 1, 2, 3. So you have to get 2, 3. So 8 sets, 2 cube. That is here 3 elements. So 2 cubes. So you have to get 8 sets. So now write the subsets here 1, 2, 3 and 1 2 one set, and 1 3 one set, and 2 3 one more set, and 1 2 3 one more set, and empty set. So there are 8 subsets. 3 elements, so 8 subsets. Next one is 5. So the subsets only one here empty set. Empty set, there are no elements. That means n is equal to 0. So 2 to the power of 0 is equal to 1. 2 to the power of 0 is 1. So there is only one set. So here you can write a set 5, or this is an empty set. Either only 5 or this set empty set. So you can write like this, only one set. Now please do these similar questions. These are from R.D. Sharma. And here are the answers.